Hello, everybody. So this is fellow project group YHK. Our topic of the fellow project is driver drowsiness detection. Our team include myself, Yu Hui, and Wei Jie. And this link of GitHub and include other materials of our fellow projects. So first, I would like to introduce the background. So studies have shown that more than 10,000 car crashes are caused by drowsiness driving every year. So driver drowsiness detection will help reduce such accidents. So the objective of our project is to build a high-efficient deep learning model for drowsiness detection. So for the data side, we used to train our model was downloaded from Kaggle, which contains around 700 images per neighbor. And the neighbors include closed eyes, open eyes, yawn, and no yawn. For the goals, first we will build a deep learning model for image classification. For phase 2, we will do face and eye detection. And in phase 3, so we will apply our model for video object detection. So in phase 1, first we process and label the input images. And because the images are irregular, so we rescaled all the images to a unique size. And then we labeled the images with 0, 1, 2, 3 for these 4 categories. After that, we split the 10% of the data into to be validation data. And finally, we get around 2,600 images for training and around 300 images for validation. So here shows the architecture of our model. So basically, our model includes 2D convolution layers and the fully connected new layers. And we used IDEM to optimize the model, and the batch size, we used 10 images, and we trained the model for 200 epochs. As you can see here, after training, the validation accuracy can reach to about 70%. So then we realized there is really no practical significance in determining whether or not to yawn. So we just deleted these 2 categories and only included pictures with open and closed eyes to train the model. As you can see here, after training, and the validation accuracy can reach to around 90%, which is amazing.
In phase 2, we define the functions for eye detection using DLib. The face detector in DLib is made using the Hawk feature with a linear classifier, an image pyramid, and a sliding window detection scheme. Also, it worth noting that this method is much more accurate than the implements in OpenCV, so we did this one in our project. There are 68 landmarks that can be detected in this model, which are shown in the left figure. We will calculate the circumscribed rectangles of each eye's points as the result. Similarly, the whole face is labeled in a blue rectangle. Here are 2 images as the example of visualization. The left one is the input, and the right one is the output. The face is labeled in blue rectangle, and the eyes are labeled in red.
Hey, this is Vijay. I work on the phase 3 of this final project. So in phase 3, we are going to have the proper use of the model. As Chunlin and Joyce already explained in phase 1 and 2, we collect the data set, develop the model around it, classified it, and when you starting looking at a big picture in a complete scene, a person face can be anywhere and also eyes can be anywhere. We have to direct it. So we train the model with two classes, closed eye, open eye, and also we use the detection method OpenCV. So now my job is I have to develop a pipeline such a way I have to input a video and I have to get the output as a video with annotations. So that is my job. So how I'm going to do it? So in a pipeline, I capture the video by loading the video in the memory and analyze each frames of the video. So before I going into it, so these videos are captured using normal camera to show the capability of our model. In future, like I should not say like this model will work only with the high quality definitions camera, nothing like that. So when I show the demo, the video is taken by with the normal camera. So once we analyze each frames are nothing but images. If you have a video of 10 seconds, there will be at least 300 frames in the video, right? So in our what our model will do is like it will take at least 30 frames, and if the first 30 frames, if the eyes are closed, then it will say tells the model. So we are directing the method where eyes where is the eyes in terms of a rectangular box, as already Joyce told. We will crop the eyes and send the cropped eyes to the model to detect the eyes closed or not. And as I said, it will analyze the frame by frame. And if in a frame, if it like at least almost 30 frames, if the eyes are closed, it will tell the model the eyes are closed. We even calculate the center of the eyes. The centers are used to define the region of interest with original width 10% more, and same for height as well. So once the eyes are closed, we detect that we have the results that eyes are closed. We are using those results to annotate on the video. We are using matplot library to annotate. And final is we have to get the output of the video. We're writing the video using OpenCV. And also we added an alert message for the user to when the eyes are closed is or more than or equal to 3 seconds. Going to the next slide. Here I have the three different images. One is eyes are open. You can see a green rectangular box and a blue rectangular box, which tells which is face and which is eyes. In the next image, the green rectangular box turns into a red because the eyes is closed or greater than 3 seconds. And in the next image, we have an alert message on top of the rectangular box says like the eyes is closed more than 3 seconds. So now in the final slide, I'm going to demo the video, what we have done, what throughout this project. So before that, I want to explain, like I have tried three different scenarios. One is when the eyes is closed, close to 3 seconds. One is the eyes is closed more than 3 seconds. And another is the, the eyes is closed not even a 3 second, like blinking the eyes. And finally, eyelid left to right. So I will show you each one. Chunin, please play the video. Yeah, so now you have the green rectangular box in the eyes. Now the eyes is closed and you can see a alert message there. The next is that's again the same scenario, more than 3 seconds. You can see the alert message there. And the next scenario is I'm going to blink the eyes, no alert message, right? And the final scenario is I'm moving the eyelid left to right to making sure our model is detecting the eyes, not the eyelid. So the three different scenarios explained here is like when the eyes is closed more than 3 seconds, you get an alert message. So we derived this using our deep learning techniques, whatever we studied in the last 2 months, using our Python techniques. So in a real life situation, we allow this model. This model will help the driver when the driver is drowsiness, and this model will alert the driver that you close the eyes more than some time, and it will avoid many accidents. That is our motto of this project. So I think we explained the project well. Thanks for listening. Thank you.